and welcome to today's lesson. So I believe you've been going through the notes that I presented in the previous video. So from where we ended, we're going to proceed and look at the type of a simple machine called the pulleys. So we gave examples of simple machines. We said we have what we call the inclined planes and also the levers. Then we cited some examples. So we'll be looking at those types of simple machines one by one. So for today we'll start with the pulleys. So we understand that this is just a type of a simple machine that helps us to lift things. Okay, so this is just a type of a simple machine that helps us to lift things. So we'll look at some examples of pulleys. So we have, let me say types of pulleys. So types of pulleys. So the first one we look at is a single pulley. So we have a single pulley. Then two, we have what we call the fixed pulley. Then we have what we call the movable pulley. Then the last one, we have what we call the combination pulley. Sometimes this one is referred to as the tackle pulley. So these are the types of pulleys that we have. We have a single pulley, a fixed pulley, a movable pulley, and a combination pulley, also known as the tackle pulley. Now, we have to understand what is a single pulley, what is a fixed pulley, what is a movable pulley, or a combination pulley, which we call the tackle pulley. So we'll start with this one, the single pulley. So let me just write it down there. So what is a single pulley? So a single pulley, so I'll just say, so this is a pulley that just reverses. It reverses the force, let me say, it reverses the direction of the force. So that's a single pulley, just a pulley that reverses the direction of a force. Now, we can categorize single pulleys into two. So we say we have these types of pulleys. Now, when you talk of the single pulley, so we have a fixed pulley. A fixed pulley can be considered to be a single pulley, provided there is only what? One pulley. And again, a movable pulley can be considered to be a single what? Pulley, provided it's just one pulley. Then again, a combination. Just from this term there, we can be able to define a combination what? Pulley. It means that this is when we have two or more pulleys combined. So that's why we call it the tackle pulley. So meaning that a fixed pulley can also be a combination of pulleys. A fixed is the one that is not moving. It's fixed on some obstacle. Then a movable pulley is the one that is moving. So we can combine two or more moving pulleys, two or more fixed pulleys. So we can consider these two to be single pulleys. Again, these two to be combination pulleys or tackle pulleys. So when you talk of a single pulley, it's just the one that reverses the direction of the force. So let's go to the fixed pulley. So on the fixed pulley, so this is an example. We know that when you talk of pulleys, these it contains the ropes and the wheel. So the wheel, this is the one that we call the pulley, and we have these the ropes. So when you look at this, so this system is what we call the pulley system, where we have the wheel and the rope. So now types, we have, this is a fixed pulley, so it is fixed. This pulley is fixed to this obstacle which is there, it is fixed. It cannot move. So this one does not move. Now, if you look at, we have this rope that is wrapped around this wheel, and this is where the pulling force is, or the effort. So this is where the effort is applied. Imagine you want to lift this load which is there. Then you want to lift it. So you'll be pulling on this other end. Now, the question is, we know that simple machines, they are supposed to help us reduce the effort that is being used. Now, when it comes to a fixed pulley, it does not reduce the amount of work that is supposed to be done. Remember, I said simple machines, they do not reduce the amount of work that is supposed to be done. It only reduces the amount of effort. So it is going to reduce the amount of effort that is supposed to be applied. Now, when it comes to a fixed pulley does not reduce the amount of work, one. It does not reduce the amount of effort. So, even if you put this load, you connect it to a rope, then you want to lift it. It is same as just lifting it with your own hands. It does not reduce the amount of effort. So, meaning if you have 100 newtons there, if this is 100 newtons there, meaning the amount of effort that you're supposed to apply, it is also 100 newtons. So there is no difference by just lifting it up. Meaning that, in fact, you're supposed to apply more effort because you're supposed to overcome this force. If this is 100 newtons, then you're supposed to apply 100 newtons plus. So meaning it's more than what you're supposed to lift there. So this weight is the same as the force that you're supposed to apply. That's why I've indicated, if you're using 100 newtons, even there you need to use 100 newtons so that you overcome or lift this thing. The only advantage that this one has is it can help us to move these loads to a height where we cannot reach. So it is going to help us move this load to a height that we cannot reach. So that's the only advantage that is with the fixed pulley. But it does not reduce the effort. It does not reduce the amount of work. Now, looking at this rope is pulling downwards, like that. So we can have the mechanical advantage for a fixed pulley. So MA, which is by now I'm sure you understand, this is a mechanical advantage. So the mechanical advantage for a fixed pulley is equal to 1. The mechanical advantage for a fixed pulley is equal to 1. Why are we saying 1? It's because this one, the rope that is pulling, it is pulling downwards. It's not supporting this pulley. It's not. It's pulling downwards. So we only have one effort which is there. So we are simply saying the effort. Let me say this is a load. Sorry. Then this is where the effort is. So we are simply saying effort is equal to what? Is equal to load. So the effort is equal to load. So what are we trying to say? We know that VR is equal to what? Effort over load. Which is equal to, we know what is our effort? The effort is 100. So this is 100. Then what is the load? Is 100, which is equal to 1. So the VR is equal to 1. If the VR is equal to 1, meaning that even MA will be equal to 1. So you just have to know that for a single fixed pulley, and it is pulling downwards, it's fixed, which is pulling downwards there, meaning that the MA is equal to 1, and the VR is equal to 1. And we assume there is no friction force. That's why we have so we can simply say this is equal to MA is equal to VR, which is equal to just what? 1. So MA is equal to VR for a single fixed pulley. Okay, now we move on to the next type of a pulley. So we have the movable pulley. So if you look at this one, this is a movable pulley. We have this pulley and we have these two ropes that are supporting this pulley. So this pulley is supported by two ropes. Why are we saying it is supported by two ropes? It's because this one is lifting. So it is supporting this pulley, it can't go downwards. It is being supported by this one and also by this rope. So what is it is there, if you are pulling from this side, this will be moving, the pulley and the load will be moving together. That's why we call it the movable pulley. The pulley and the load will be moving together. So this kind of a pulley reduces the amount of what? Effort. If, for instance, I've given this is 100 what? Newtons. So meaning that the lifting force or the effort that you're supposed to apply will be half over the weight over the object there. So meaning you only have to apply what? 50 newtons. So this one reduces the amount of what? Effort. Why? Because it is being supported by what? 2 ropes. So this one and this one. So we can simply say we have this one that is moving upwards. So this is where the effort is, and this is your load. So if you apply the effort there, this thing is going to move upwards. So for short, if you want to find the velocity ratio and the mechanical advantage, it's just a matter of counting the number of ropes that are supporting the pulley. So this one, it is supported by 2. We have this rope and also this what? Rope. So it is supported by 2. So we can simply say we have this one and this one. Why are we saying it is supported? This one is going upwards. Unlike this one which is going downwards. When a rope is going downwards like that, we do not count this one. This one, it is not counted. It is not supporting, it is pulling it downwards. So the only one that is supporting is this one, because it's going what? Up. So that's why we are saying it has got the MA is equal to 1 and the VR is equal to 1, because only one rope is supporting it. There we have 2, because this one is going upwards. We have 2 that are supporting the pulley. So for this one, we'll simply say MA. The MA is equal to, just count the number of ropes. 1, 2. These are the 2 ropes that are supporting this pulley. So this is equal to 2. So this is equal to 2. And we can simply say we know that MA is equal to load over effort. So according to what I've given there, we have the load is 100 there. We can simply say this is equal to 100 over 50. So that one and that one goes. So it will give us MA is equal to 2. That's why we have a 2. So it's proving to say it is being supported by 2 what? Ropes. So these are the supporting what? Ropes. That's why we have MA is equal to 2. So on this one, the movable pulley, provided it is a single, the MA is equal to 2. You can just know this now. We know that when it's a single movable pulley, is MA is equal to 1 and the VR will also be equal to 2. So the VR and the MA, these are supposed to be equal. Mind you, we have to take note of the direction of the effort. If it is moving upwards, you count that rope. If it is pulling downwards, you don't count the rope. So the last one, we have the tackle pulley or the combination what? Pulley. So when it comes to the combination pulley, this is when we have 2 or more pulleys combined. This is when you have 2 or more pulleys combined. So a good example is this one. We have this pulley and this pulley. So we have 2 pulleys there, or 2 wheels there. And this is another type. So there we have 1, 2, 3, 4. 1, 2, 3, 4. So we have 4 pulleys there. There we have 2 pulleys. So that's what we call a combination or a tackle pulley, when you combine the pulleys. Now, you may be asked to find the VR, also the mechanical advantage. So if you look at the load which is there, so we have, this is a fixed. I'm sure you can see it is fixed. This one cannot move, but this one, it is not fixed anywhere. So if you pull down there, this one will be moving upwards. So this is a movable pulley and this is a fixed pulley. So we've combined the 2. So as you can see, this one reduces the amount of effort. The more you put the pulleys, the more the effort is going to be reduced. So if you put more pulleys there, meaning you have less what? Effort. But you have to be mindful. meaning that the rope is going to be lengthened. You have a longer what? Rope to pull. That's the only disadvantage which is there. So this is 100 newtons. 100 newtons, it is going to be reduced to 50 newtons, meaning the effort is what? Reduced. Mind you, I say it is not the work that you're reducing, but the effort. The effort that you're applying is reduced there. Now, we want to find now the VR. How do you find the VR there? Let me just put it like that. So to find the VR, or the mechanical advantage, so I'll start with the VR, which is the velocity ratio. How do I find the VR? We know that it's just a matter of counting the number of ropes that are supporting these pulleys. The number of ropes that are supporting these pulleys. So if you look at this pulley here, it is supported by this rope. So we have 1. Then we have 2. This one, it is supported by this one and this one. So we have 1, 2 ropes which are supporting these pulleys. Now, why are we not considering this one? This is where the effort is. We are not considering this one because it is pulling downwards. Once it is going downwards, this one is not partaking in the supporting of these two pulleys. So this one that is going downwards, it is not counted. We only consider these, the ones that are supporting. So this one, if it was going upwards like that, we would have counted it. Now it is going downwards, so we cannot count it. So the VR is equal to the number of ropes that are being that are supporting what? The pulleys. So we have 1 and 2. Or for short, it's just a matter of counting the number of pulleys or the wheels. We have 1, 2. You just count this 1 and 2. So this will give us the number of, the velocity ratio. So what is the VR there? So the VR is equal to 2. We are considering what? The number of what? Ropes. The number of ropes. So 1, 2. Or you just count the number of wheels. 1 and a 2 there. So that's your VR. Now, a good example, another one we can look at is this one. Let's find the VR for this one. So, let's find the VR for this one. Okay. So, we are saying we have to count the number of ropes that are supporting the pulleys. So, look at this one. We have this pulley. So, this pulley is being supported by 1, this rope, then 2. So this one, then you come to this one. This pulley is being supported by this one. So we'll say 3. Then we have this one, which is 4. So if you count, you have this one, 1, then 2, 3, then 4. Why are we not counting this one? So this one is not counted. Why? It is pulling downwards. So the number of ropes there that are supporting these pulleys, we have 1, 2, 3, 4. Just a matter of counting the number of ropes. Or for short, you can count the number of wheels. We have this wheel, and this wheel, and this wheel, and that one. So 1, 2, 3, 4. So the number of wheels is equal to the number of ropes that are supporting the same wheels. So the VR for this kind of a pulley system is equal to 4. So this is what you're supposed to take note. So there are times they will ask you to find the VR and also the mechanical advantage. So for the mechanical advantage, they will give you the force, the load, they'll give you, and the effort. For instance, they'll give you something there, so you have to use the forces that are being given for the mechanical advantage. And also they can ask you to find the efficiency, of which understand it is equal to mechanical advantage over velocity ratio times 100%. So for now, I expect you to go through these the same explanations I've given. Then try to answer some questions. You can find some questions because I've explained the way you're supposed to find the VR in the pulley system, and also the mechanical advantage, which is just the load and the effort to be given. Then on these two, these you just have to understand, just know them. To say if it is a movable pulley and it is a single one, the VR is equal to 2 and the mechanical advantage is equal to 2. Then for a fixed one, it is equal to 1. So the VR and MA, they are what? Equal. So go through and make sure you answer some questions. So this is where we end today. We'll continue next time. Thank you.